Right, so hopefully, the last video, hopefully. Right, so I was going through the concept of independent, trying to remind myself how it works. Sorry, I'm just trying to find this on. Right. So A, B, and C are three events. A and B are independent. So I was going through independent events there, and I was saying that the probability of A occurring given that B has already occurred, that first formula I have there is the conditional probability formula. So A intersection B over the probability of B. And then the second thing, so like this thing here, is the probability that A occurs given that B has already occurred is the same as the probability of A. That's if they're independent. So essentially, B occurring has no effect on A. Yeah? So this one here is, sorry, got that slow. Did that work? There you go. So that thing I've underlined there is the probability of A happening if B has already happened. And what I'm saying is that B happening has no impact on A. So that's why it is equal to the probability of A, because they're independent. It has absolutely no impact. And then what I did was I equated the two right hand sides. So I equated this one and that one. Oh my god, it's so slow. There, it worked there. Okay, so I equated those two in yellow. And that's how I got this line. And then if you rearrange that, so essentially what I did was I multiplied across by the probability of B. And that gave me the final line. Okay, so let's have a look. So A and B are independent. So if they're independent, if they are independent, then this is true. So is that helpful? Let's see. The probability of the intersection is given as 1 over 12. The probability of A is 1 over 3, and then we don't have the probability of B. Yeah, so that's just subbing into this yoke here. So to isolate this, if I divide by a third and divide by a third, so 1/12 divided by a third is a quarter. And that's the probability of B. Okay. So we want to find B intersection C. Okay, I don't know. I'm going to do a Venn diagram. I don't know if it's going to help. I'm just trying to understand B and C here. So if that's B and that's C, so B intersection C is what we're trying to find. So B intersection C is like this bit here. Which is what we're trying to figure out. We have the probability of B is a quarter, but that's the whole thing. So like the probability of B is a quarter, but that's like this whole, do you know what I mean? It's like the whole circle. And then we also have the probability of C, which is up here. See that? Probability of C. But again, that's the whole thing there. And then we are told that the probability of the union is 5/8. So that I have written it there, but that's that there. See, the union of B and C is 5/8. Okay, so if I add a half and a quarter, because that's B and C, I get 3/4. Now, is 3/4 bigger than 5/8? Okay. So the probability of B and the probability of C is a quarter plus a half, which is 3/4. And 3/4 is the same as 6/8. Okay. So that means there is an overlap because 6/8 is bigger than 5/8. So the overlap then, I think, is that it's just 1/8. If I do 6/8 minus 5/8, I get 1/8. So if I put 1/8 in there, and then to get what's left in B, I do a quarter minus an 8, which is an 8. And then to get what's left in C, I do a half minus an 8, which is 3/8. Okay, and that gives us 5/8 total, which is what we want. Oh, what am I after doing? Sorry. Okay, so the probability of the intersection is an 8. And the fact that there is an it says investigate whether B and C are mutually exclusive. So the fact that there is an intersection means they're not mutually exclusive. Because if they were mutually exclusive, then I shouldn't say 0, then there won't be anything in the intersection. So they are not mutually exclusive as the probability of the intersection is not a null set. Right, where are we? What question are we on? This is 7. Yeah, right, last part is 7. 7. There. So an 8, the probability of the intersection, so B and C are not mutually exclusive. 10 marks. It's actually kind of a nice question. So that's question 7, which is 10, 15, 20, 25. 25. Okay, 2 to go. Next one, similar triangles. Right. So the lengths of the sides of triangle ABC are 9, 12, and 18 units as shown. In the diagram, each side is divided into 3 segments of equal length. Find the perimeter of the shaded region. Key. So those ones are 4, 4, and 4. Okay, these ones here are 3, 3, and 3. And then down the bottom we have 6, 6, 6. Okay, I think we have a load of little like matching congruent triangles. If you have a look, right, see, like if we look at that triangle there and this triangle here. Yeah, so they're the ones I'm focusing on. I'm going to take the circles off. So that line there is, oh God, sorry. But yeah, so that, sorry, the green line I've just put in, yeah, is the same as this green line down here. So they're the same. That means these angles are the same. Yeah. And then you can do the same thing. So they're corresponding. You can do the same thing here. And you can get that these angles are the same. Yeah. So basically they're little congruent triangles. And you can do the same thing with this one over here. Yeah. So I'm just going to take all those markings off. And that one. Okay. So God, it is so slow. So yeah, basically then the shaded region you should be able to see hopefully with the colours is 6, 3, 4, 6, 3. So 6 plus 3 plus 4 plus 6 plus 3. I wonder how much of a proof they wanted for this. What's that? 9 and 9 is that 22 units? Oh, did I just add wrong? Sorry. Yeah, okay. They didn't want any kind of a proof. They'd probably like if I added right. So is this 6? Yes. This is 3. 6, 3. This is 4. Yes. This is 6. This is 3. Oh, I didn't add that one in. Sorry. I forgot the last 4. So you do not need a proof, but you do need to add it correctly. So that is 10 and 10 is 20, 26. It's 26, right? Yes. Excuse me. Okay. If the area of triangle ABC, which is the big triangle, is 48 square units, find the area of the shaded region. Okay. So we know the 3 little baby triangles are the same, so we can figure one of them out. We can just multiply by 3. So if I take let's call this ABC, this X and this Y. Right, so if I take out that triangle AXY, I'm just going to draw it down below, and I'll bring you down in a second. So that is AXY, and that is 6, 4, and 3. And then I'm going to draw the main triangle, which is ACB, and that is 12, 9, and 18. Oh, is this actually like an enlargement? Because we can't actually, we know all the sides, so you can see that they're multiplying by 3. So do you remember in enlargements we have the so the area of the image is k squared times the area of the object. I think we should be able to get it from there. So the area of the image is 48. The scale factor, as in what it's enlarging by, is 3, isn't it? Yeah. And that is, so 3 squared times the area of the object. So if I want to isolate the area of the object, I'll just divide by 9. Divide by 9. So that is, I'm getting 5.3 recurring. Ugh. Yeah, so that means this is 5.3 recurring. Oh, actually, sorry, the 0.3 might work out because I have to multiply by 3. So if the whole thing is 48, and then I'm taking off 3 triangles, each of which is 5.3 recurring, that will leave me with the shaded bit, won't it? So the whole thing is 48. Yeah, I think that's right. So I'm going to multiply that by 3, which is 16. 48 minus 16 is, so I'm getting 32 units squared for the shaded bit. Yeah, I think. I'll just put it down in the actual box. Let's have a look. Yeah, 32. Did I get a mark for the last one? The last one was worth 5, and this one is also worth 5. Right, so in the diagram, CD, where am I? CD is parallel to AB. Okay, AC is perpendicular to AB, fine. AD and BC intersect at O, yeah, AB is 11, CD is 9, and AC is 12. Prove triangles ABO. So ABO is this one. and CDO, okay, are similar. So similar is equiangular. So we're looking for the same angles. They've told us that these are parallel, which means oh, okay, this is actually grand. So I've got this. We'll wait patiently for it to appear. That, which means that this is equal to this. So let's name that. So angle DCO equals angle ABO and Y because they're alternates. We get that with the Z. Then I can go the other way. So angle CDO equals angle BAO because they're alternates. So exactly the same reason, just the other side. And then the third angle, so to prove that all the angles are the same, is going to be the one in the middle here. Anyway, here. So I can do this and this. So I can say that angle COD equals angle AOB. And the reason there is that they're vertically opposite. So they're similar because all triangles are the same. It was quite a straightforward proof. 5 marks. Okay, find AD and hence find OD. Find AD and hence find... Okay, so AD is just this one here. And this is a right angle triangle. So it's just Pythagoras. So hang on. So this is C, this is D, this is A. Oh, Jesus. Sorry, it's so glitchy. 9 and 12 is what I have. There, so this is 9, that's 12. Okay. Is that D or O? That's D. Okay, so AD squared equals 9 squared plus 12 squared. So then we have 81 and 144 is 11664. And then, oh my god, oh there you go. Square root and square root. Square root of the answer is 108. Is that right? Hang on. That absolutely is not right. Sorry, I must have multiplied those two. 81 plus 144 is 225. And the square root of the answer is 15. My God. Always important to check that your answer makes some sort of sense. Okay, so that's 15 units for AD. And then hence find OD. Okay, so do I need similar triangles again here? Because it's not split in half, I don't think. I'm going to flip this triangle here, kind of upside down if I can. So I'm going to make this O, this D, and then this C. So this is the yellow one, C is the green one, and O is the red one. Sorry. Yeah. So then between yellow and green is where the 9 is. Okay, and then the big... Yeah. I don't know if I'm using the right triangles. Anyway, the other one, which is the one at the bottom, I'm not going to flip. So it's O, A, B. This is 11. This is red. This is yellow. And this is green. So, sorry, I know I'm doing this all over the place. It makes more sense to be looking at the picture. So I know that A to D, right, that whole yellow line is 15. But how is it split up? So if I do 11 over 9 equals, so I did big over little, so it equals OA over OD. Okay, so that means OA and OD are split in the ratio 11 is to 9. Okay, so I'm just going to do it this way. Yeah? Did that come up? No, of course it didn't. So those two together make 15, but I need to split it up in the ratio 11 is to 9. So anytime you're doing ratios, you add up 11 and 9, which is 20. You take the thing you're trying to split, you divide it into that many parts. So that means 0.75 is 1 part. So OA is 11 parts, which is so annoying. Sorry, so you add your ratio up, you take what you're trying to split up, divide it by the ratio, so that then you have 1 part. So 1 part is 0.75. OA is 11 parts, so I multiply 11 by 0.75 and I get 8.25. I can't remember which one they actually wanted, so just bear with me for a second. So that's 8.25. And then to get OD, it is 9 parts, which is 9 times 0.75, which is 6.75. Okay, so the question was OD, so 6.75, I think. I don't know, was there a cleaner, oh, let's check it's right first, I suppose, but I don't know if there was a cleaner way to do that, but it is right. Oh yeah. So 10 marks for both of those answers. So that is 10 and 5 and 5, so that's 20, 25. The dogs are out of bed. So 25, yes, 25 is correct. All right, and then the last one is a bit of statistics. And we are done then, finally. Right, so farmed salmon are harvested when they grow to a certain length. The lengths of the salmon produced in a particular offshore fish farm are normally distributed with a mean of 32.8 and a standard deviation of 2.4. Find the proportion of salmon which are more than 35 centimeters. Right, so that is a Z-score. There's no sample means here, so it is just a regular old Z-score, I think. What am I doing? Sorry. So x minus mu over sigma. So we don't need the square root of n because there is no sample size for us to put in. Okay. So the number we're testing is this one here. Sorry, that one there. That's what the question's about. So that's 35 minus. This is the mean, the mu, and the mean is there. So mu is the mean and the mean is there. So that is 32.8. And then sigma is the standard deviation, and the standard deviation is 2.4. So 35 minus 32.8 divided by 2.4 is, so 0.917. I can only look up 2 decimal places, so 0.92. Okay, so just less than 1 standard deviation above the mean is what we're talking about. And the question says more than. So we are looking for the probability of the Z-score being greater than 0.92. Okay, so 0.92 is like there, just before 1. And we are looking for the probability of the Z-score being greater than that number, which means we're looking for, we're looking for it being over here, to the right. We can't look up greater than in our book. So, excuse me, this is where we do the entire probability of the whole thing, which is 1, minus the probability of the Z-score being less than 0.92. So that's where we get, so 1 is the entire probability, it's 100%. And then we're going to minus off the probability of being over here on the left, and that will leave us with the probability of being over here, which was what we want. So less than 0.92. Oh, there it is. Okay, so 0.92. So 0.8212. 0.8212. So that is 1 minus 0.8212, which is 0.1788. So it just says find the proportion. So 17.88%. Yeah, 17.88, 10 marks.